In this video lecture, we'll be looking at exponential method. So this method returns the base of the natural logarithm e to the power of the argument that we are discussing about. So let's look at this example. ArcSine 11.635 to the variable x, and this is a double. So using system.out.println, I have exponential brackets %.3f. What this means is that the precision is going to be 3. If you take it down to 2, it will go to 2, and that's all. So we can change it to 5, 6, 4, 3, 2, or any precision of your choice. We're going to check it out when we run this code. Alright, so let's go ahead and run this code so you can see it. Java is going to give us the answer immediately. So exponential 11.635 is 112,983.83831. Okay, let's change this to 4. Let's change this to 5, and let's change this also to 2, or let's change this to 1 so that we understand this. The precision will change. You can see this 11.63500 because 5 precisions and 112,983.8 because I put precision of 1 for the answer. So this accepts 3 arguments, one a string and the other one is a method, and our x here. So I believe you see that, and I pass the argument x into this method, and x is 11.635. So I hope you really see that, and you can play around with it. If you have any problem, please try to use the question and answer section, and I will get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we'll be discussing about logarithm method for numeric primitive data types in Java programming. Okay, in Java programming, logarithm has its own method that we use to be able to calculate functions concerning logarithm, and this is known as the log method. So let's go ahead and look at the example just very before us. We have a double of variable x with a value 9.465. So you're going to pass the value of x, an argument, into this math.log. So you pass an argument x here, and this is going to help us to print out the result of the logarithm with 3 precisions for both this here and the result. So let's go ahead and run this and check it out. So the log of 9.465 is 2.248. So you go ahead and try this with many other ones. Let's go ahead and change these values like 7 and run this code again. So the log of 7.465 is 2.010. So let's go ahead and change this to 10.0, and let's see what it's going to give us. Okay, go ahead and run this. Let's check what we're going to get. So it's 2.303. So check it out on your own, and let's make sure that you are really getting just decent thing here. This is about logarithm method in Java programming. I believe that it is clear and you can be able to play around with it. In case if you're having any issue, please don't fail to get back to me, and I'm going to get back to you as soon as possible. All right. So thank you so much, and I'm going to see you in the next video lecture as you go ahead and put down this on your laptop now and start practicing. Thank you, and see you in the next video lecture. In this video lecture, we'll be looking at the power method in Java programming. Power method is one of the most useful methods we have in Java programming today. So, this is just normal, like the most of the powers you use. I know some of us will be asking, what is a power method and why do we use it? This method returns the value of the first argument raised to the power of the second argument. Let's, for instance, we have a calculator here, and I have x assigned with a value of 9.729 and y, variable y, with a value of 4.987. So if I go ahead and raise 9.729 to the power of 4.987 equal to 84,624.503. So when you approximate, so let's keep this in mind and go ahead and run this code. You can see that Java actually gives you back exactly what we just got right now. So let's go ahead and run this code and see it. Run this code, and Java is going to return this back to us. So you can see that the power of these two arguments, 9.72 with 9.729 raised to the power of 4.97987 is 84,624.503. So whenever you want to build some applications that will be using power method, you can easily do this. This accepts two arguments, x and y only, and you can go ahead and try it out on your laptop and see how it works. It is just very easy and very interesting. So I believe you're going to check it out, and in case if you have any issue, I'm going to always be here to help you out at any point in time. Just try to use the question and answer sections, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we will be looking at SquareRoot method in Java programming. Okay, as we've discussed many methods, so this is one of the best methods that most of us will be looking at as far as we're working with mathematics in Java programming, and that is the square root. We've all known about square root, and Java has a method that they use to calculate square roots. So I have a variable x of a double type, and I assign 1.738 to this variable. Now, using the square root method, let's go ahead and get the square root of 7.738 and make sure that this really works out fine. But before we go ahead doing that, let's go ahead and use a calculator to check it out first, okay? Because that will help us to know that this is really working out fine before we can be able to check it out and run the code very before us. Okay, 7.738 square root is equal to 2.782. Remember that we are using 3 precisions in this course. So let's go ahead, as we've known that the square root of 7.738 is equal to 2.782. Let's go ahead and use the square root method in Java programming to check it out and make sure that we are really getting exactly the same thing. Okay, so the code is just very before us right now. Let's go ahead and hit run right now and check it out. Alright, the square root of 7.783 is 2.782. So I believe that you can see that what we have on our calculator is just exactly the same thing we have right here. Alright, so what we're going to do right now is go ahead and play around with this and check out many other things and many different figures. You can use different data types to check int, short, long, float, and double as well. Just play around with it and make sure you have fun checking it out. This is the square root method here, and try to pass your argument to this as I just pass my x onto this. So at this point, I believe you are really enjoying this course because it's now really coming into the real world applications of day-to-day activities in mathematics. Okay, we've come to the end of square root method, and I believe that you really understood this. But in case you still have any question under this lecture, please try to use the question and answer sections, and I'll get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we'll be looking at another interesting method known as the Sine Method. So, in Java programming, we have a Sine method which we use for checking out the sines, and we also have a cosine method, but in this particular video, we'll be looking at the Sine method alone. Okay, this method returns the sine of a specified double value. It is usually double at this point, and here we will be working with degrees and radians in case you want to get it. So you're going to create a variable for this, and you go ahead and check the corresponding radian, and you pass the argument to the sine, and that should be the radian. So the code is just very before us, so let's go ahead and check it out. But before we go ahead doing that, let's use our calculator to check out this to make sure that this is really working out fine before we can be able to say yes, this is right or wrong. Okay, this is my calculator here. I'll go ahead and put a 125 sine, and I believe you all have this calculator for people who are using Windows at the time you are watching this video, but I don't know if this is actually just same a Mac. I've not checked it out before I started making the video, but if you're using Windows, you can check it out. We also have a programmer's calculator which you can always check out in case you are working. Just come over here and click on this, and you have options here for different calculators. Like you can check out a programmer's calculator in case you are working on something like the bitwise operators. But for this purpose, you just keep it at scientific and go ahead and follow me. So the sine of 125 is 0.8192. Okay, let's go ahead and check it out to make sure it is actually just the same thing, and that this sine method actually works fine in Java programming. Alright, so go ahead and run this code right here. The sine of 125.0 degrees is 0.8192 in radians. So I believe that you're already getting this, and you've seen the importance of using Sine method in Java programming, because Java is so big that you can use anything you need. So there will be a time when you will need this in programming, and then you go ahead and use Sine Method, and it's going to work out fine. Alright, we've come to the end of Sine methods in Java programming. I believe you really understood this, and in case you are still having problem anywhere in this particular lecture, please try to use the question and answer section, and I'll get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we'll be looking at Cosine method in Java programming. Okay, we've discussed the Sine method, and we believe that you understood the Sine method very well. Now, we have a cosine method, just similar to Sine method. So, in case if you are looking for a cosine method you want to use in Java, the code is just very before us on how to use a cosine method, and you pass the argument to the math method math.cos. So I'll be checking out cosine of a 1 to 5. I'm going to check with other numbers, but before we go ahead doing that, let's use a calculator as usual to check out and make sure this works out fine. So 1 to 5 cos is equal to minus 0.574. Okay, let's come over here and run this code right now to check it out. Alright, you can see that the cosine of 1 to 5 is degree is minus 0.574. In case if you approximate, if you didn't approximate, it's going to be minus 0.5736. So you can see that. Let's go ahead and check out other numbers here. Let's say 45, and go ahead and run this code, and you're going to get that 45 degree is a 0.7071. So let's check it out on our calculator again. 45 cos, you can see that 0.7071. okay, this is about the cos method. I believe that it's just very easy for us, and the code is just still very before us. Please go ahead and try it out on your own laptop, put it down, and check it out. In case if you're getting something awful or you are getting confused along the way, please try to use the question and answer section, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. Welcome back again. In this video lecture, we'll be looking at tangent method in Java programming. Okay, we have every mathematical methods that will help us to solve all mathematical functions in Java programming. In fact, Java is a complete language that I love so much, just because it has everything that we need. So we have a tangent method, and we'll go ahead and look at how to calculate mathematical functions or tangent in Java programming precisely, because that is what this particular video lecture is meant for. Okay, so by the time you finish this course, you're going to learn about so many other methods, and that's going to help you in case you're working on some mathematical stuffs that need them, so you can be able to pick up the methods of your own choice and start working on them. Alright, so we have this code just very before us. I know by now you might have put it down, or you go ahead and wait. Let's check out the tangent of 1 to 5 and any other one we want on a calculator before we go ahead and run this code right now. So checking out the tangent of 125, 125 tan is equal to minus 1.4281. Here we are using 4 precisions. So let's go ahead and also check 45 tan is equal to 1. Okay, go ahead and run this code for 125 and let's check it out. So the tangent of 125 degree is equal to minus 1.4281. This is what we got actually. So on our calculator, let's go ahead and check also that of 45 degree and see what it gives us. Run this code again and you can see that the tangent of 45.0 degree is 1.000. I hope you can see that, and that is what we got from our calculator as well. So you can see that all these functions, all these methods, they actually work very well. So the code is just ready before us. Go ahead and put down this code on your laptop and check it out. And this is what you'll be using in case you want to calculate the tangent of any number in Java programming. I believe that this is just very easy and straightforward. In case you are having any issue, please try to use the question and answer sections and I'm going to get back to you as soon as possible. Thank you so much and I'm going to see you in the next video lecture. In this video lecture, we'll be looking at the ArcSine method. So previously we've looked at the Sine method in Java programming. I believe that we understood that, and now we are looking at ArcSine method in Java programming. So we use the ArcSine just the normal way the calculator gives us our ArcSines. So we'll be checking out this in Java programming to see how we can be able to do that. So this is the code that will help us to do this in Java programming. I have put down this so that you can be able to follow up immediately. So go ahead and put this down on your laptop and let's go on and check out some degrees and get the ArcSine of their results. So the ArcSine returns, this method returns just the ArcSines of the specified double value. That is what we are looking for. So go ahead and run this code, and it says the ArcSine of 0.8129 is 55. So the sine of 55 is 0.8192 and the ArcSine of 0.8192 is 55. So that is what ArcSine is. In case you don't know what ArcSine is, it is the corresponding value of the sine output. So let's go ahead and put 45 and check it out. So the ArcSine of 0.7071 is 45 degrees. Because the ArcSine is usually in degrees, and you can get the results of sines in radians, and that result is what we converted back again to give us the degrees, and that is called ArcSines. So I believe that you've learned about sines and the ArcSine and when to use them, and henceforth you can begin to use them in Java programming. And in case if you're having any issue with this, please put your questions on the question and answer sections and I'll get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we will be looking at the ArcCosine in Java programming. So we have a method called ArcCosine. The ArcCosine is going to give us back the corresponding value of the cosine degrees, and just like the ArcSine works just exactly the same way, but this is because this one is cosine and the one we treated before is a sine. So these are two different ones, ArcSine and ArcCosine. So let's go ahead and check out the value of 45 in ArcCosine here in Java, and after then we go ahead and check out 1 to 5. So the program is just very before us, and I hope you put it down on your laptop and check it out as well. So go ahead and run this code, and the ArcCosine of 0.7071 is 45 degrees, and let's go ahead and change this to 1 to 5. Let's check it to 55 and go ahead and run. So this is what we got, and you can be able to try like 90 and check it out. It's going to give us 0, because most of us don't know that cos 0 is equal to 90. All right, cos 0 is equal to 90. So whenever you want to check out the ArcCosine, whatever it gives you is just exactly the right answer. So this is all about ArcCosine, and I believe that you've understood it, and you've seen the method that we are using. So you put this down on your laptop and check it out on your own, play around with it and put different values to know if you're actually getting what you're supposed to get at the end. And in case if you're not getting that, or you're having issue with any part of this lecture, please put your questions on the question and answer sections, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we will be looking at the ArcTangent method in Java programming. Okay, we've discussed the tangent and sine, cosine, and other methods. Here we will be looking at the ArcTangent, and I'm very happy that we have all these methods in Java programming, because it helps programming to be very interesting. It makes it to be interesting and very easy as well. So you can see the code for doing this just very before you, so you can go ahead and put down this code in your laptop and check it out. You can check out different degrees and see what it will give you, and I'll go ahead and run this, and we can see that just here. So you put down different values and see what it gives you. So I believe that this is very easy, and you can be able to follow this step by step. And in any way you have issue, please just let me know and I'll get back to you as soon as possible. So I believe that this is all about ArcTangent, and go ahead and put down the code on your laptop and check it out too. And for any reason you are battling with this, please use the question and answer section and I'll get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video, we'll be looking at random number generation in this course. So in this course, or in Java programming, we have a method that allows one to generate random numbers. Just in the case you're wondering how does one generate different password for users? When a user forgets a password, the machine automatically generates a default password and asks you to go ahead and change your password. How is this being done? So in this course and in this video lecture, we'll go ahead and learn how to generate different numbers using what is called random method. So this random method will generate different figures for us. It is called math.random, and you don't pass anything, and there's no argument passed in here, and it will continue to create random numbers for us or for the user. So go ahead and hit on run. The code is just very before us, and put it down, hit on run, and you can see down here numbers are created for the first system.out.println, for the second one, and for the last one. If I go ahead and run this again, it will generate a different values entirely. I hope you can see that. And if I keep running this, it will keep creating different values for me. I hope you can see that. It is called random method in Java programming. So put it on your system and check it out. And in here, you are not passing any argument here, so just bear that in mind. And I hope that it is really straightforward and very clean. So check it out, and I will stay here and make sure that you put everything down on your laptop. All right, so for any reason you have a question concerning any of these, please use the question and answer section, and I'm going to get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we'll be looking at how to change to degree using degree method. So Java has a method called degree method. So you can be able to move numbers and change them to degree. And we also have a radian, which you use to change numbers to radians. So I have two variables of double type, assigned the value of 90 and 45 respectively to variable x and y respectively. So I'm going to pass this as an argument to degree method. So when I run this code, they will give me the degree of 90 and 45 respectively. So go ahead and hit on run, and this is the degree of 90, 5156.62, and 2578.31. So this is how you get degrees of numbers in Java programming. So check it out and try it on your own. If you are having issue, please put your questions on the question and answer section, and I'll get back to you as soon as possible. Thank you so much, and I'm going to see you in the next video lecture. In this video lecture, we will be looking at Radian method in Java programming. So in Java programming, we have a method called Radian method, which you can use to convert numbers to radians. So like our degree method, where we convert numbers to degrees, I have 90 and 40 respectively assigned to x and y of a double type each. So you pass this to argument as an argument to the method to radians. If we go ahead and run this code, we'll be getting a radian output values for 90 and 45 respectively. So let's go ahead and hit on run and see what this gives us. So for 90, the radian is 1.57 and for 45 it's 0.79. So go ahead and check it out and try it on your own system, and in case there is any issue, please use the question and answer section. The code is just very before you, and I'm going to be glad to help you out in case if you're having an issue anywhere. So thank you so much, and I'm going to see you in the next video lecture.